Okay, so today's notes are on factoring special cases. Our content objective is to recognize special cases, including the difference of squares in perfect square trinomials, and our language objective is to use the correct terminology to describe special cases. So the first special case that we're going to talk about is the difference of squares. So one side thing I want to know is both of our special cases involve perfect squares and identifying them. So I want to make sure that we're clear on or identifying them. The difference of squares is when you have two perfect squares that are being subtracted. So a squared minus b squared, or if as long as the coefficient of these terms are perfect squares, it could still work the same way. It's always going to factor the same way. It's going to factor to a plus b times a minus b. So these are called conjugates. So conjugates are the same binomial with opposite middle signs. So same binomial, opposite middle signs. So the difference of squares always factors to the conjugates or to conjugates. So a and b, the square root of the first term, square root of the second term added and then subtracted. So this is the most common special case we will see. So I really want to make sure you guys are okay identifying it. So difference of squares. Our first example, we're going to factor 25x squared minus 49. So one thing critical, they always need to be subtracted. It's the difference of squares. So it's not, this does not work if they are being added. It only works if they are being subtracted, and I can show you why. So the first step, we have to identify that they're perfect squares. So I know 25 and 49 are both perfect squares. X squared is a perfect square. So these are indeed perfect squares. So our first step is to recognize that. And then we're going to take the square root, or we'll write recognize. So one way you can, or that might help you identify it, is if we have a binomial, so this is a binomial, two terms, then it's either not factorable or it's the difference of squares. So that's one key indicator is if you are asked to factor a binomial, chances are it's the difference of squares or it's not factorable. So recognize the difference of squares, and then we find the square root of both terms. So the square root of 25x squared is going to be 5x. The square root of 49 is going to be 7. Last step, I'm going to write in factored form or write as conjugates. So I'm going to rewrite this as 5x, since that was my first term, plus 7, and then 5x minus 7. And that will be my answer. I'm going to put a little note here so you can see why this works. So I'm going to have us check our answer in this instance so you can see why this ends up this way. So if I had 5x plus 7 times 5x plus 7, or sorry, minus 7, that's a minus, not a plus. It's a minus sign. Then I'm going to FOIL it. So I do first, I get 25x squared outer minus 35x inner plus 35x, and last minus 49. So because I have plus and minus, these middle terms cancel out. So negative 35x and positive 35x undo each other. So you end up with just 25x squared minus 49, which is why the difference of squares will always factor this way, and it always will work out just fine. So let's do a quick check together. I want us to factor each of the following. So first one, we're going to do 16x squared minus 81. And the second one, we're going to do 1/16 k squared minus 1/4. So we're going to try those ones out. I'll go over them now. So I know the square root of 16x squared is 4x. The square root of 81 is 9. So I'm going to factor this to 4x plus 9, 4x minus 9. And that will be my answer for that one. This one I'm going to do the same thing. So I did the square root of 1/16 k squared. When you take the square root of a fraction, you just take the square root of each part. The square root of 1 is 1. Square root of 16 is 4. K squared, or square root of k squared is just k. Then I have the same thing. Square root of 1/4 is going to be 1/2. So then I can write my factored form as 1/4 k plus 1/2 times 1/4 k minus 1/2. And that is my fully factored form. So this works even, that's why sometimes these look really messy and difficult. They're not that bad once you get them, or once you recognize that they are the difference of squares. So the next one I want to talk about is perfect square trinomials. I'm less concerned about you recognizing perfect square trinomials because these will factor, or you can factor these without identifying them. So a perfect square trinomial, while it can save you time if you recognize it, you can factor it just like we've been factoring the past few days with the middle term splitting method, or if a is 1, you can just factor that way. So, but the perfect square trinomial is the square of a binomial. So we've actually already factored a couple of these. It's going to take the form, or it would be if you had something like a plus b squared, and it will always be, or the trinomial version of this would be a squared plus 2ab plus b squared. So what this might look like, I'll do an example. If we were to factor x squared plus 10x plus 25. Oh, I forgot to say this real quick. Stop, email me, and let me know you're listening really quickly. So pause for a second, email me, let me know you're listening to the notes. I'm going to continue with this example, but please send me an email, let me know you listened. All right, so back to the example. First thing, you have to recognize that the first and last terms is perfect, or recognize the first and last terms as perfect squares. So I know x squared is a perfect square, 25 is a perfect square, so that checks out first and foremost. So then you're going to check that the middle term, b, is twice the product of the square roots. So this sounds like a lot, and if it is more confusing for you, you don't have to do this. But I know the square root of x squared is just x. I know the square root of 25 is 5. And I know 2 times 5 times x is 10x. So 2 times 5 times x is 10x, which is indeed my middle term. So that works out. And then I'm just going to rewrite this as my square roots squared, added and squared. So 3 right, the binomial with the square roots. So this would just be x plus 5 squared. And that would be my answer. Again, I'm less concerned about you recognizing a perfect square trinomial because you can factor those normally and then just rewrite it once you realize you have 2 of the same binomial. But if you are conscious of it and you recognize it, it can save you some time and effort. Let's do one quick check together before we go. I want us to factor 64x squared minus 16x plus 1. So again, try it on your own. I'll go over it. The square root of 64x squared is just 8x. Square root of 1 is just 1. I know that 2 times 8x times 1 is going to be 16x, which is indeed my middle term. This time, since it's negative, I know that I need to account for that. So I'm going to make my in-between sign negative. So since this is negative, I'm also going to write 8x minus 1 squared. And that will be my answer. All right, make sure you write down any questions, comments, or concerns you have so we can go over them together in